Hey everybody, today I'm going to be doing a video pretty much exclusively on Desmos, so you won't see my face today. But I just wanted to show this really cool thing I found a few months ago that I've wanted to make a video about for a while, so I'm going to share it today. So here I have this typical sine curve, just sine of x, and you can see here it's 1 over m times sine of x, where m is just equal to 1 for now. We're going to mess with that a little bit later. Um, but yeah, so I was just playing around. I was thinking of, okay, well, what if we had some sort of equation here? Like this looks like the equation of a circle, right? And I just set it equal to 2 because why not? Um, and so pretty much, you have the equation of a circle. The only difference is that we have an f of x here, where f of x is obviously our sine graph. So I was thinking, okay, well, what would that turn out like? I forget exactly what I was trying to do. I had an objective, but then I ran into this and I was like, wow, this is much cooler than what I wanted to do. So basically, I want you to kind of think like, what do you think is going to happen? This is the equation of a circle, but that one coordinate is a sine graph. Oh, actually, now I do remember what I wanted to do. I wanted to make it so that it was a circle that traveled along this path. It was just a normal circle that would just, go up here and then down here and, something like that. And that's what I wanted to do. And I don't know if that's what some of you think is going to happen, but it's not. And it's much cooler, actually. So yeah, so okay, so this A actually here, this is just this coordinate, basically our X position. Um, so that's not really that relevant. It's just the thing that's gonna make it actually move across here. But yeah, so I'm gonna turn this on and you can see like this is not a circle. And at first you might be like, why does it look like a potato? Um, and it doesn't make sense at first. It's like, well, that doesn't look at all like a circle. Like, I mean, it's kind of round. It's like an oval, but it's not even a perfect like ellipse or anything. So let's just watch this as it travels. So you can see it kind of just like it's really cool. It's like this blob, and that's why I called it blob here. And it's really interesting. It's just traveling along like that, and I could make this period like bigger or whatever, but um, I just wanted to kind of show like what would happen. It's just like wow, this is really cool. Now this got me thinking, and after a little bit, I started thinking like, wait, this is kind of what a circle would look like if the world was like not like a straight line but a weird curvy thing. So if like this is hard to explain, but like if you had a surface and the surface, let's say the earth, because the earth, of course, like from our perspective, like the ground is just flat. It's like a flat plane basically, but of course we know it's not a flat plane. It's a whole sphere, a gigantic sphere, but because we are so small relative to the earth, we just perceive it as a plane. Now if the world looked like kind of a sinusoid here, this is basically what a circle would look like. It's a circle from the perspective of the ground, like this. And you can have this for a range of functions. Let's say we had yeah, let me kind of just show you. Let me duplicate this and let me introduce a g of x where our g of x is equal to e to the x. So let me hide this and this, and let me just kind of run this again. And you can see, let's wait until it comes back down. Yeah, so it looks like a circle here, but then whenever it goes up, it kind of just shrink, like kind of shrivels up, and then it goes like that, and it's just really cool. So normally, so you can see here when it's like over here, it's just a normal circle, and that's because we have like basically a flat line. But then whenever we have a like over here, this is where it is. It is over here. See, it's highlighted there. It's just this flat thing, and you can see how high it goes. Like, look at that. Look, like, I don't even have the whole thing on my screen right now. Still not. It goes all the way up to y equals 500. Isn't that crazy? That's just so just bizarre. And you can another cool one is tangent of x. Whoa. Let's go back here. Okay, there we go. So here's tangent of x, and you can see it's just this like it looks like a leaf basically or whatever, and it's just crazy. It's just the way it just travels like that is insane, and I just thought this was like super cool, and I hope you guys appreciate this as well. So let me get rid of this one, and let's stop this for now. So now let's adjust M. And it's not gonna do anything too crazy, but you can see like when oh yeah, so this I think is the thing that kind of made me realize that this is just what a circle would look like. Um, if M is really small or really big or really negative here, if it's really big in magnitude, you're gonna look more and more like a normal circle. Like you can see, I just paused A right now, and if I adjust M, like if it goes closer and closer to zero, you can see it's gonna look just more stretched out and bizarre. But if M goes to a higher magnitude, it just looks like a circle. It's going to look more and more like a circle. And you can see that it's just going to travel almost like an exact circle. So if m goes to infinity, then this is just going to be exactly a circle. But if m is 0, then let me make m exactly 0. Then of course it's not going to exist because we have 1 over m, but we can make m just super small, and you can see you can see it's basically just a straight line, and you can see it just traveling, and it's really cool how it just travels like this and that. I don't know. I just find these things really cool, and we can adjust M and A at the same time, and we can see that it's just gonna be really, really weird, and it's gonna act just really strange. But yeah, so now let's pause this and this for now. Let's make A 0 again, and then let's make M 1. I'm gonna get rid of this, and I'm going to instead, actually no, I want to get rid of this. I'm gonna instead use this. This is basically the same thing, but instead of squared, I'm putting 100 in the exponent, and that makes really cool shapes. And of course, because it's such a high power, it's really hard to like work with. But you can see kind of them. It's like this kind of squarish shape inscribed. Um, and if we make M really big, you can start to see that this is exactly, it's not a square, it's just, like if I zoom in, you can see it's not exactly a square, it's just a really sharp edge, and that's because that's kind of what it would look like. Because I can say we have x, uh, actually, yeah, so x to the 100 plus y to the 100, if that's equal to 2, then you can see that's just going to look like that. Again, not a square, but it's really close to a square, especially as these exponents go to infinity. Um, so yeah, this is basically what a square would look like in a wacky world like this. So if m is 1 again, it looks kind of like a flag, right? So we can, it's kind of laggy because of just how insane this is, but you can kind of see what's going on just as it moves around like that. And we can make m, change again. We can make both of these change and just, I don't want to keep that on too long, but yeah, that's basically just a weird kind of interpretation. And I just think it's super, super interesting. And I'd like to see if you guys know anything more about this. If any interesting other things that I can like learn about, because this is really cool, and I'd like to investigate this a lot more. I just don't know what to look for. But yeah, I just thought I'd share this with you guys. So I really hope you enjoyed. Thank you guys for watching, and I'll see you in the next video. Bye guys.